Good morning. Today we are going to discuss shift registers. Shift register. Shift register means we have already discussed flip flops. Flip flop means it's a main component of a sequential circuit and it can store one bit of information. That means a flip flop can store one bit of information. For example, suppose that if you want to store one bit of information, you need one flip flop. For storing 2 bits, or if you want to store 2 bits, then you need 2 flip flops. If you have 3 bits, 3 flip flops, and if you have n bits of information to store, you need n flip flops and a group of flip flops. Here, suppose that you want to store a group of n bits in, then you need group of n flip flops. Here, group of n flip flops. Okay. Now, what's a register? What's a register? Register is actually it's a group of flip-flops that store group of bits. For example, suppose that this is a 4-bit register. Here you have 4 bits, then this is 0, 1, 2 and 3. Here we have a set of 4 flip-flops. 4 flip-flops. Usually 4 flip-flops for constructing registers we use D flip-flops. Why? As you know, this is the characteristic truth table for D flip-flops. That means if D is 0, this is the characteristic diagram. That means this is a truth table for D flip-flops. And if D is 0, the previous state is 0, then that will be set to 0. And whatever be the value of the previous output, if D is equal to 0, if the current D is 0, the output will be 0. The next for the next transition, that means the next output value of the flip flop will be 0, regardless of the previous input. The next input will be 0, regardless of the previous output. Next input will be 0. See here, if it is 0 and 0, this is in both of these cases it is 0. That's why here we have zeros. And in this case we have two ones. That means the value of D input, that means D3, if D3 is 1, then definitely after triggering Q3 will be 1. If D3 is 0 after triggering, that means whenever this is negative edge triggered flip flops, and whenever you have a trigger, if D3 is 0, definitely Q3 is 0. That means regardless of the previous value of Q3, if D3 is 0, Q3 will be 0, and D3 is 1, Q3 is 1. That means for setting a flip flop, setting it, you have to give 1, and for resetting it, you have to give 0. That is why we are using D flip flop. That means this is the simple form of this. That means regardless of what the value of the previous output, if your input D is 0, definitely the output will be 0. It will be reset, and if it is 1, that will be set. Okay, that is regarding D flip flops, and this is an example of a shift register. This is an example of a serial in, serial out. This is SISO, serial in, serial out shift register. Here you have D3, D2, D, or this is flip flop number 0. This is flip flop number 0. This is 1, this is 2, and this is 3. Okay, this is 3. And as you know, here the output of this Q3 is connected as the input of flip flop 2. Output of second flip flop is connected to as the first output of flip flop number 1, and this is connected to this. Okay, that means here we are going to see how this is working. This serial input, serial output, shift register, how it is working, that we are going to discuss. See, initially, suppose that the value of These are all zeros. Suppose that here this is 0, here we have 0, this is 0, and suppose that this is 0. Initially that will be 0, that means all D3 values D3, D2, D1 and D0, Q3, Q2, Q1 and Q0. Definitely if D3 is 0, D3 is 0, then D2 is 0, that's why D2 is 0, D1 is 0 and D0 is 0. Okay, Q3 0 means D2 is 0, Q2 0 means D1 is 0, Q1 is 0 means D0 is 0 and Q0 is the output. Okay, now this is a common clock is given to all the flip flops, and each flip flop is storing one bit of information, and that is this. That means here initially all the flip flops are the output of the shift register. That means this flip flop is storing 0, this is storing 0, this is storing 0, and this also is storing zeros. Okay, now suppose that for the next cycle, suppose that this D3 is 1, that means I am going to give an input of 11012 to this D3. That means for the first clock cycle, I am going to apply this one over here. Okay, that means for the first clock cycle, that means clock is like this, clock is like this. That means this is the negative edge trigger, this is the negative edge, and whenever this negative edge triggering happens, then depending on the value of D, the output of that flip flop will be set. That means suppose that here initially I am going to give D3 as 1. Now definitely the previous value of D2 is 0. 0, 0. Then what will be that means now this is the D3, D2, D1 and D0 values. So when after setting this, when that trigger happens, negative trigger occurs, when that negative trigger occurs, what will happen? As D3 is 1 and the trigger, then definitely this Q3 will be set to 1. And D2 is 0, that's why this D2 is 0. That means here initially you have 0 and definitely Q2 will be 0. As D1 is 0, Q1 will be 0 and D0 is 0, Q0 will be 0. Okay. Then after that, this is the first clock pulse. First, this is the second, this is the third, and this is the fourth. Okay. When the second clock pulse occurs, when the second trigger occurs, we are going to have, that means I am going to store this 1101 into this 4 flip flops in a serial fashion. That means this is the most significant bit and this is the least significant bit, and I am going to provide this one by one. During the first clock pulse, I have given this one as D3, and during the next clock pulse, that means once this happens, after the first clock cycle, what are the values of Q3, Q2, Q1 and Q0? Now Q3 is, what is the value of Q3? This is 1, this is 0, 0 and 0. Okay. Now this 1 is stored in this register or this flip flop. Now this 1 is stored in this register, and that is why we have Q3 equal to 1. Now I am going to give the next value, that means 0, to this D3. Now D3 is 0. See, now D3 is 0. What is the value of D2? D2 is the value of Q3. D2 is the value of Q3. That means Q3 is directly given to D2. As 1 is stored in this register, definitely D2 will be 1. And D1 is what? D1 is Q2. What is Q2? That is 0. And D0 is Q1. Q1 is 0. That's why we have 0. Okay. Now, this is the second clock pulse. And when that second trigger occurs, depending on the value of D3, D2, D1 and D0, definitely Q3, Q2, Q1 and Q2 will be set or reset. That means as D3 is 0, Q3 will be 0, D2 is 1, Q2 is 1, D1 is 0, this is 0 and D0 is 0, this is 0. Okay, now this phase is over. Now I am going to give 1 to this. That means now the third for the next third cycle I am going to give the next one. Now this is 1 and what is the value of I am going to give D3 equal to 1. That means next bit I am going to provide. Okay, that means for the first clock cycle I have given this 1. For the next cycle I have given 0. For the next cycle again I am going to give 1. Okay. Then what are the previous values of D2? D2 is, so D2 is Q3. Q3. Now once I have given this, now the value of Q3, Q2, Q1 and Q2 are 0, 1, 0, 0. That means now this is 0. This is 1. This is 0 and this again is 0. Okay. Now what I am going to do, I am going to give the next input as 1 and the previous values of D2 is, what is the value of D2? That is Q3 which is 0. What is the value of D1 which is Q2 which is 1 and what is the value of D0 which is 0? The previous value of Q1. Q1 is equal to D0. So the previous value. That means now the values stored in this register 0, 1, actually it is 1, 0, 1, 0. Why? When this trigger occurs, that means when this negative trigger occurs, what will happen? As per the value of D3, D2, D1 and D0, the values of this will be set or reset. Now that will again be 1, 0, 1, 0. And for the next clock cycle 4, now this one is stored in this register. That is why we have 1, 0, 1, 0. The outputs are for this 1, 0, 1, 0. Now those are the values. And now again you are going to give the next one. That means next one to D3. That means now this 1. Then what is the value of D2? D2 is actually this. Once you have done this, what are the values of the output of this is 1, this is 0, this is 1 and this is 0. 1, 0, 1, 0. And now see what are the values of D3, D2, D1 and D0. D3 is the next bit I am providing. What is D2? D2 is Q3 which is 1. What is D1? D1 is Q2 which is 0. And what is D0? D0 is Q1 which is 1. That is D2 is Q3, D1 is Q2, D0 is Q1 and the output is Q0. Now depending on now the next clock pulse negative edge trigger, when the trigger happens, when the trigger occurs, what will happen? Depending on the value of D3, D2, D1 and D0, the values of these flip-flops will be set or reset. And then that will again be 1101. That means when you did this, that means after four clock pulses, you have stored this value into the four flip-flops. That is why you have serially inputted, or the input is serial. That means serially for one clock pulse you are giving one bit, for the next clock pulse you are giving the next input, and likewise for storing 4 bits you took only 4 clock cycles. Now after 4 clock cycles, your 4-bit data is in this flip-flop or in this set of flip-flops. Okay. Now once you have done this, if you want to take it serially out, what you have to do is, now you are going to give, that means these are the 4 bits you have stored here. That means the input is now, or the flip-flop is having the information 1101. Okay. Now you are giving 0 0 0 0. That means another 4 bits you are going for another 4 bits you are going to provide. That means in the serial fashion again. That means initially we are going to give 0, then again 0 0 and 0. Okay. Suppose that you are going to give 0 as D3. That means this is the 5th clock cycle. Suppose that you give 0 here. What is the previous value of, what is D2? D2 is the previous value of Q3, which is 1. What is D1? D1 is the previous value of Q2, which is also 1. And what is D0? D0 is the previous value of Q1, which is 0. And what is the output? Q0 is 0. No, it is 1. Now this is 1. This is 1101. 1101. This is the stage now. This is the stage right now. And again you are going to provide 0 as D3. And the previous value of Q3 is D2, that is by 1. This also is 1. This is 0. Okay. For the 5th clock cycle, the values are 0 1 1 0. Definitely this is 0 1 1 0. Then definitely this will be set as 0 1 1 0. And we have already taken this 1 as output in the previous. Now here the value of Q0 is now 0. That means now the values are 0 1 1 0, and now the output is 0. Okay. Now for the 6th clock pulse, the values again we are going to give this 0 here. Now 0. What is D2? The previous value of Q3, which is 0. D1 is the previous value of Q2, which is 1. This again is 1. And when the negative edge trigger occurs, this will be set to 0 0 1 1, and this is the output you have taken, and that is this one. Okay. Now this is set as 0 0 1 1, 0 0 1 and 1. Okay. Now for the 7th pulse, again you are going to give 0 here. That means the next 0. Okay, 0 you have given. Now what is D2? The previous value of Q3, which is 0. Previous value of Q2 is Q3. What is D1? The previous value of Q2, which is again 0, and this is 1. And when you are triggering this, what will happen? This will be 0, 0, 0, 1. Now you have to take this as output. That means this also is output, this also is output. Okay. Now you have set this 0, 0, 0, 1. 0, 0, 0, 1. And this one you have taken. Now it is 1, 1, 0, 1. Okay. 1, 1, 0. That means 1, 1, 0. That you have for the first 4 clock cycles, you have stored this 1, 1, 0, 1 into this set of 4 flip flops, and for the next 3 clock cycles, that means you took 4 clock pulses for storing and 3 clock pulses for retrieving means for retrieving the last one, that means in this phase itself, that means here after this 4th clock pulse, the data stored in this last flip flop can be taken. So you need only 3 clock cycles, another 3 clock cycles for retrieving this information. So if you have an n-bit shift register, you need n cycles for storing and n minus 1 cycles for retrieving. So this is an example of serial in serial out. That means you are serially inputting data and you are taking it back serially. Serial input and serial output. Okay. Then suppose that if you want to retrieve this parallelly, that means I am going to a minor modification for this is, if you want to retrieve this parallelly after 4 clock pulses, what is the information? 1, 1, 0, 1 is there in this as output. 1, 1, 0 and 1. That means after 4 clock pulses, you have 1, 1, 0, 1 in this 4 flip flops. So after that, if you are going to take it out parallelly, that means you are retrieving that information all the flip flops at the same time. That means from Q3 you are taking an output, from Q2 you are taking an output, from Q1 also you are taking the output, from Q0 you are taking the output. Here this will be 1, 1, 0, 1. 1, 1, 0, 1. Okay. That means this is serial in parallel. That means no more clock cycles. After 4 clock cycles, you have successfully stored your data into this set of 4 flip flops, and once you have done it, no more clock pulses are needed to retrieve the information from if you are doing it parallelly. Okay, it is very easy to do that. Then for your syllabus point of view, you need only discuss serial in serial output and serial in parallel output. So if you want to input that parallelly, what you can do is there is no need to have this. Okay, no need to have this, and then what are you going to do? If you want to give 1, 1, 0, 1, if you want to store 1, 1, 0, 1 here parallelly, here you have to give 1, here 1, here 0, and here 1. And after that, for a single clock pulse, for a single triggering, if you do a single clock pulse, if you are providing a single clock pulse, for after that, this 1101 is stored in the set of 4 registers, that is parallel in. Parallel in. Okay, that is parallel in. And if you want to provide that serially, parallel in and parallel out. Okay, parallel in and serial out. There is no need to discuss that again. That means anyway, there are two kinds of inputs. Input is either serial or parallel. Output is also serial and parallel. That means this is S, this is P, this is S, and this is P. Then using that, you have 4 different combinations. That means SISO, SIPO, PISO, and PIPO. So we have discussed this, and we have discussed parallel also. So at this point in time, you need to discuss only serial in, serial out, and serial in parallel.